Okay, this is where we left off, yes? This looks like stuff. Rationals. Okay, so when we start this one, we're going to add. So we need a common denominator. So I'm going to factor anything I can. So remember your factoring styles. You got to go through them and make sure you know how to find them. So here they are. Ready? We have simple trinomials, complex trinomials, GCF, difference of squares, and then in this unit there was one more that we just talked about, negative out. So there's 5. There's always 5. First thing, good. Second, this is a GCF. I can do x out, x plus 3. Then the last one is a simple, so 2 brackets x multiplies to 3, so 3 times 1, and then I need a plus 2 out of it. Okay, so we're going to pick a common denominator, so you're going to have to think, what do I all need to have in my bottom? Okay, so I'm going to need an x plus 3 in there. I'm going to need just an x, and I'm going to need an x minus 1. So this bottom would fit in there, this would fit in there, this would fit in there. So that works. Okay, so now we're going to talk about what do I have to multiply by. So the first fraction had that, so now I would need to multiply by x and an x minus 1. The second fraction had an x plus 3, so I need to do by an x minus 1. And the third fraction had that, so it was missing x. Okay, what is my big hint when you're multiplying 3 things together? Do you remember that? Multiply 2 things together, and then you can go by the third. So this would be x squared minus x. X squared minus x. Then I'm still going to have to multiply it by 5 after. So 5x squared minus 5x. All right, now the next one. This is where I trick a lot of people. Don't forget it's a negative 2 that goes through the multiplying. Okay? Don't forget to make that negative 2 go through everything. So minus 2x, and then this is usually where I catch the mistake. Plus or minus plus 2. And then the last one would be plus 4x. Okay, so just be careful on the distribution stuff. All right, and then I would ask you to simplify it. So we have 5x squared. All that I can put together. So what does that become? Minus 3x. And that's it. Okay, so collect anything on the top if you can, and that would be all you can do. Okay, multiplying or dividing. So we're going to factor. We have first first, a difference of squares. So can you give me 2 sets there? On the bottom, can you give me a GCF factoring on that? And then on these, can you do 2 simple trinomials yet? All right, so I got a 4 and a 1. And on the bottom, I'm going to use a 2 and a 1. Are we all matching? Okay, if this question had a divide sign instead of a time sign, what's the one thing I would do differently if there was ever a divide? Flip and multiply, yeah. Because I don't see an example of that, so just to make sure you know to flip and multiply. Okay, I'm going to look for cancellation, so something has to be on a top bottom to cancel. So x minus 1, there's an x minus 2 top bottom, there's an x plus 2 top bottom, and then that is it. Okay, we all know that the x's don't cancel here because they're connected with adding, right? So something like this, the 5's don't cancel. That doesn't make sense. You don't cancel unless it is connected. This would cancel because they're multiplied. This is not because it's added. Okay, we all understand that? That's a big concept to understand. Don't cancel them there. Okay. Solving. So when I solve rationals, I had 2 big ideas. You could either common denominator drop or cross multiply. So when you look at this one, do you do a common denominator drop or do you do a cross multiply? Common denominator. So that's my first setup, is just 2 fractions on the sides and thinking, what do I need to make my bottom? 3x. Okay, so that's the setup, and then we go through what's the multipliers now. Okay, so if this bottom was just an x, I'd have to multiply by 3. This was a 3, so I'd have to multiply by x, so I multiply by 3. Okay, so once I multiply that out, I get 15 minus x equals 3. Okay, so now that's where I can just drop the bottom, because if the bottoms are the same, conclusion, the tops have to be the same. Okay, so algebra, I'm going to minus 15. And I'm going to divide by -1. Is 12 a solution that could work, or is it something that I would say is a restriction? What don't I ever want x to be? 0. I can't have x be 0. That would be bad. Okay, with that in mind, what can't x be on this answer? I can't have x be a what? -3 or a -6. Those are the values that you cannot have as answers. So if you ever got an answer, you would have to cross it off and say, no, it doesn't work. Okay, when you're looking at this, you're saying, should I common denominator drop or should I cross multiply? Cross multiply. So that and that's the setup. Okay, so we're going to do this. I have to distribute those. What would you ever do if you had two binomials timesing each other? What do you have to do in math when you have a binomial and another binomial when you multiply them? FOIL. This is a monomial binomial, so that's what you're doing, but two binomials, make sure you're foiling. Okay, the next step is your step that shows you can get into grade 12 pre-calc. What do? Equals 0. You have two variables, x squareds and x's, so you're going to have to do an equals 0. Okay, so when I get all this together, I can do those two together. So 6 minus 8, so minus 2x, and then minus 24. I can't put those together, right? They don't match up together. Now that we have an equals 0, we can go through the, can I factor? What style do I have? If I can't factor, I have a quadratic formula. So 2 brackets. Does anything multiply to 24? 6 times 4 minus 6 plus 4. And this is good because when we talked about our restrictions, that was a -6, which we don't have. We have a +6, so that's fine. Okay, rational word problems. Okay, you have a 10-liter solution, so there's already chemical in here. There's already chemical in there. If 3% of that is chemical, what do you do to figure out how much chemical it is? 10 times 0.03. Okay, 3% is 0.3 liters of chemical in there right now. So that's our total mixture right now, and that's our chemical. Now we're going to add more chemical in. We're going to put more chemical in. Do I know how much more? No. I'm just going to add more. So here's the little strategy on these. The chemical in there divided by the full fluid is showing you how % strong it is. So the chemical started with 0.3, then I added more. The total fluid started at 10, but I added more fluid. It doesn't matter what fluid you're adding, water or chemical, it's just fluid. And I want to end up with 5%. So I'm going to write it as a fraction. Some of you might write it differently, like a 1 over 20. Some of you might write 0.05 over 1. Okay, that's the setup. Now we pick the strategy. So common denominator or cross multiply. Let's cross multiply. So 30 plus 100C equals 50 plus 5C. Now, which algebra strategy would you go with on this? This one is only one variable. You only have one variable, so it's an isolate. So let's group the C's together. Group the C's and then move the 30. Okay, I'm going to divide by 95. And I get 0.21 liters of chemical you're going to add up to this. Okay, 3 people are working, Nick, James, and Lisa, so we're going to do a chart. And then we're going to talk about time and rate. So set that up and then we'll read. So the time is always when they're working together. The rate is always when they're doing something alone. That's their rate. Okay, James did the yard by himself, 52 minutes. So James' rate. Nick by himself would be 58. That's a rate. Lisa by herself would be 48. That's a rate. So all together, how long would it take if they're all working? So that's, I'll call it X actually. They're all going to work for X amount to do the job. Okay, so now we're always going to set this up. The time over rate is the job they did. The time over the rate, job they did. So that's each person's job. They did a time over a rate. When all 3 of them do their jobs, the total amount of job is the one job. Okay, cross multiply, common denominator, common denominator. And this doesn't look very fun. So I'm not going to pick the lowest one. It doesn't matter here. So I'm just going to go that. Okay, I just times all 3 of them together. Okay, so 1, 4, 4, 7, 6, 8. Okay, ready? So this divided by 52 means I'd have to multiply this by 2784. Okay, if I do that divided by 58, means this one would be 2496 to multiply to that. Okay, so dividing by 48 now means I'd have to multiply by 3016. Okay, how many x's do I have altogether? So I'm going to add all three of those up. So 8296x, that, and that. How many x's did it make? How do you ever write 1 as a fraction? You just write the same thing over the same thing. That's the idea of writing a 1. Okay, so now at that point I'm dropping the denominator completely. So this has to equal that. I get 17.45 minutes when they all work together. Good? So when you're finding a common denominator on that one, you don't have to do the lowest, so just when you multiply all of them together, that's the common. Okay, the other question is also a time rate with a Johan and a Samantha. They're changing oil in the car. It takes them 20 minutes. So that's the time they work together, 20 minutes. If Johan did it by himself, it would take 35 minutes. So how long would Samantha take if she did it by herself? Okay, same idea. Time over rate is the job that Johan did. Johan did 20/35 of it, plus the time over the rate that Samantha did. Together, they do the whole job. Cross multiply, common denominator drop. That's your next question for yourself. So common denominator. So I will need to put a 35x in the bottom. Okay, what do I need to do for multiplying? So 35, so this is by an x. This was an x, so now I'd have to multiply by 35. And then, how do I write a 1? Same thing over a same thing. Okay, 20x plus 700. this is where I can drop the bottom. I can drop the bottom now and solve. What solving technique do I use? Do I use isolation or equals 0 stuff? So this would be an isolate. So minus 20x. And divide. So Sam takes 46.67 minutes alone.